Good afternoon, everyone. Nice to see you all to attend the webinar. So once again, accept Zoom platform. We have broadcast the webinar at Facebook too. Okay, you may type Utah for you, like our page in Facebook, and share this live session to your friends. So let me introduce myself. Okay, I'm Jeffrey, Education Advisor from Division of Program Promotion, Utah. Okay, welcome, and we are happy to invite and have our speakers here today. Dr. Gobi Kannadasan, he is a head of program from Department of Petrochemical Engineering, Faculty of Engineering and Green Technology, Utah. Okay, and we have another speaker, Dr. Sin Jin Chung. He is an associate professor from Department of Petrochemical Engineering as well. So we have both our speaker. They are from FAGT Utah, University Tunku Abdul Rahman. So the topic we would like to talk about in this webinar is World Without Science and Engineering, the importance and shortcomings. So let me introduce you the webinar details. This duration will take approximately 1 hour, include Q&A session, as Zoom is our main platform for this webinar. So if you have any question, you may click the Q&A button in Zoom and leave your question. And lastly, we will introduce you Utah program and contact details of Utah. So now I will pass the floor to our speaker today, Dr. Gobi.
Okay, good afternoon, everyone. I hope you all are healthy and safe. Okay, my name is Dr. Gobi. I'm from FEGT, and I'm working as a assistant professor in the Petrochemical Engineering Department. And I've been working here for the past 4 years. And for your information, all the while, I've been graduated from chemical engineering in my bachelor degrees and in my master's, then followed by in my PhD. So my topic today would be a world without science and engineering, the importance and shortcomings. So I'll be covering the part where how would be the world would look like without the engineering as well as the science element. Okay, let us go into the presentation today, or some sort of discussion. There is a famous quote saying that scientists dream about doing great things, engineers do them or execute them. So what can we understand from here? In every aspect of our life, there is a chronicles. That means there should be an event that is happening to make it to realize a dream. So for example, let's say someone dreamt about communicating between two continents. There must be a way to I mean, I'm not too sure how was it during those in late 30s or 20s, 1920s, but there was a dream, or there was a thought of how to communicate between people in two continents, for example, in Europe as well as in Asia. So there came along the way a lot of invention came about, and in recent days we came about the internet, and now today we can't live without the internet. So there must be a dream that has to be realized, and the dream will be a very small dream, and normally this the one who initiate the dreams, or the one who had the thought of dream, we can say it, we can call them as a scientist, even though you are not a qualified scientist, but then the thought is the most important thing, and the scientist eventually will start to find way how we are going to implement our idea, or how to going to realize the dream that we have. So who are the one who are going to execute the idea, who are going to make it realize that this could be done, and so on. So the engineers are the one who execute the ideas from a small idea, from a small thought to the realization point. So what we can say here is science and engineering, they are very much interrelated. Without science, engineering is not going to exist, and science alone could not do a lot of things. It will be just merely an idea without being executed. So that's the basic idea that I would like to stress upon here is science and engineering are just like our two eyes. It is both are needed. Okay. So as we have seen in recent years, as we can see the graph over here, what we can see here is the accelerating growth in technology. If we notice for the past 50 years or for the past 100 years, the growth has been in exponential phase. What do we call as an exponential phase? Very rapid growth, and we have seen many technology has invaded into our life, and we have seen many life-changing innovations that has come across for the past 100 years. Just imagine the closest to you, probably the handphone. Okay, just about 20 years back, the phone would look like a brick. It's very heavy, it's very big. But nowadays, even a small kid can have a handphone, and it is very much light in weight, very much small in size. So those are the inventions from as it evolved along the period of time. So how do this come, the evolution happen? It is merely because of the knowledge of science and engineering. So people start to realize when they have an idea, they come up with the initial idea first. For example, as I told you, the example like the handphone, it's very big in size. People realize that it is not feasible to move it around. So what they came up with is they try to minimize the size of the handphone and so on. So without the knowledge of science, without the knowledge of engineering, this is not possible at all. So even nowadays, the recent technology is being, we can see self-driving cars and all those things. So these are the examples of the connection between the science as well as the engineering. So the importance of engineering has to be understood here first, together with the knowledge of science, before we can discuss further about the history, about the technologies and so on. So what is an engineering? So we have to understand this first. What is an engineering? Engineering is a field where you combine science, economic, and social knowledge to design, build, maintain, improve structures, machines, devices, system, materials, and processes. So these are the combination of these three major fields, which is science, economic, and social, to build the need for the people. So the most important thing is you are catering the people's need. It could be improving on the existing technology, or we could be creating something all new, altogether new. So these are the basic or fundamentals of engineering. So probably you have, I'm not too sure if you are hearing it for the first time, but engineering has been existing since ancient world. So just that some we didn't realize that it is an engineering element in it. For example, let's look into this diagram here or picture here. There's a pyramid. It was built years back or centuries back. So what happened is, can you just imagine, without the knowledge of engineering or without the knowledge of science, how could be this pyramid is built in such a perfect structure in a pyramid shape? And can you just imagine bringing a rock, a big rock, to the top of this pyramid? How could it be done? It is the evolution of technology and evolution of knowledge and evolution of science has made it happen. So people have come up with an idea on how to move a big object from a lower ground to the higher ground. This is just a very simple example for me to show there is the need of engineering in those days, even in ancient world. So people realize the importance of engineering. People realize the importance of science, and people have made so many inventions from this kind of knowledge. So for example, when we go into the Middle Age, here you are seeing a Leaning Tower of Pisa without, again, I'm telling you, without the engineering knowledge or without the knowledge of science, this Leaning Tower of Pisa would have collapsed years ago. It is only made possible to lean in such a direction where it has a degree of approximately 4 degrees. It is leaning 4 degrees. And the engineers has made it possible by making this Leaning Tower of Pisa to stand as it is now. So again, without the knowledge of engineering, without the understanding of how we could make it happen, it is not possible at all. So we have to understand the element of engineering has played a very big role in making this kind of structure to stand even today. So basically what they have done is they have given support for the building here so that it won't collapse. So it has been one of the 7 wonders of the world, and people have flocked in to view how does it look like and so on. So these are the marvels that we can say in those Middle Age. So coming back to the modern age, this is the one something very close to me, which is in my field where fertilizer, since we are talking about the petrochemical engineering, we are dealing with fertilizers. We are producing engineers who can work in the field of fertilizers. So basically what we have seen in past years, people have used poultry waste, for example, chicken waste, to use it as a fertilizer in the for the plants and so on. But as the time goes on, when the population grows, there is a need to cater the mass demand, where people need the crops for as their food, and to meet this demand, we have to find a way to enhance the growth of the plants and so on. So how do we do this? By just relying on the chicken waste and so on is not possible. So what people have come up with is the fertilizer. In this fertilizer, we can determine how to release the nutrient to the plants, where we can control the amount of nutrient supplying to the plant at each stage. We can call it as intermittent fertilizing technique. So how do they come up with this idea? As we know that it is there is a need to cater the population. So the engineers come up with an idea, what can we do? What can we do to cater this demand? So these are the initiation of the fertilizer, where release of the nutrient can be controlled and so on. So these are the examples of the application of science and application of engineering in real life. So apart from fertilizer, what do we have? The one that I'm talking about is something very close to me, or close to my field of study, or field of my research. First thing is the water. So the essential need of our humankind is the water. So as we know today, we have water sources are there, but clean water sources are very limited. So what the engineers, the water engineers, the environmental engineers, the chemical engineers, they have come up with technology to make the available water resources to be drinkable. So what they come up with is the filtration method. So there are various filtration methods that has been invented over the period of past 20 years or 30 years, where all the water resources can be converted into drinking water resources. We have to remember, water resources and drinking water resources are two different things. Water is there, for example, seawater. It is seawater, but you cannot drink the seawater directly. So we have to do something to the seawater to make it so that you can drink it. So what are those methods, or what are those techniques? It is the filtration method and so on. And some people, even in one of the our neighboring countries, they have used the sewage water to make it as a drinkable water. So how is this possible? We can't think of this idea about 40 years, 50 years back. But all this are made possible with the knowledge of engineering and science. And the next thing is then, which is a very hot topic nowadays, is the production of vaccines or antibiotics. In COVID-19 situation, production of antibiotic and vaccine is very essential, and it is still in the process. As we know that we are hearing news from the whole over the world that vaccine is being tried and tested. So soon, I believe that we will receive a first batch of vaccines available to entire world population. So how is this possible? It is not possible by just relying on the experience and so on. So we must have the knowledge. How does this virus works? How does this virus can be we can get rid of this virus, or how can we nullify the virus activities? So these are the essential knowledge that we should have. So all this knowledge can be learned in engineering as well as science. The one related to antibiotics and vaccine production is the biomedical field, biomedical engineering and so on. And of course, the next thing that I can talk about is the electricity generation from fossil fuels. We have seen this has been a very hot topic also, where people have realized that electricity generation from fossil fuels are no longer sustainable. So what they came up with is they come up with alternative electricity generation through biomass, through solar energy, and wind energy and so on. As we can see here on the left hand side, there's a picture showing a biomass gasification, where we are producing electricity through wood. We are using wood to produce electricity. Can we just imagine this about 20 or 30 years back? It is a process or evolution of technology that made it happen. So, and for your information, this biomass electricity generation could save a lot of costs, and we can save the fossil fuels being used as electricity generation as well. So we can sustain this technology for a longer period of time. And of course, the other things that we can talk about for the thing is plastics. And today we can say that the world without plastic is like just like nothing. There's no way that we can't live without the plastics. Just that in recent years, people have come up with the biodegradable plastics and so on. So why did they think of this biodegradable plastic? Because in those early years, they just thought of producing plastics. But people along the way, the scientists and the technologies, the engineers have realized that plastics alone is not the solution for the world. There should be a biodegradable element in it. It should self-degrade so that it will be friendly to the environment and so on. So these are the examples of engineering element as well as science element that has gone into our life, that has made it easier for our life and improved our life immensely. And of course, you have the petroleum engineering, petroleum production. We have seen a lot of oil rig that has been set up in offshore. And for your information, during those early years means I'm talking about 1910, 1920s and so on, people, the usage, I mean, they dig the oil, I mean, they produce the oil from the land, normally on the land. But as the time goes on, people realize that it could be done on the offshore as well. So people have gone to deep sea and started to build the oil rig to produce the oil, to rig the oil from there, and to supply it to the demand of the people. So these are the examples of the engineering element that has gone into our life, that has improved our life immensely. And of course, you have a picture of soap here. I'm sure that you learn about how to make soap in a higher secondary level of your education. So This soap is, of course, we know that in recent years there's a lot of element that has gone into our soap production, where we see the perfume, fragrance have been added to the soap. So all this possible only, again and again, I'm reiterating, only through science and engineering. So what is the role of an engineer? As an engineer, you are being tasked to transform an idea from lab scale to real scale. So you might have a brilliant idea, but if it just remains at lab scale, there's no possibility of making it to happen and making people to experience the thought that you have. So, and normally these engineers will work in a group, and this group of people will not come from one particular field of engineering. There will be someone from civil engineering, there will be someone from chemical engineering, someone will be from mechanical engineering, working together for a similar product or similar objective. And normally people will be, or the engineers will be very innovative, and especially in decision making and so on. And as we know, the necessity is the mother of invention. So people have invented a lot of things due to the necessity of the people. And to make it happen, the engineers is the one who plays a big role in it. So basically, there are four main branches of engineering. One is chemical engineering, civil engineering, electrical engineering, and mechanical engineering. And under these four main branches, there are other engineers as well. For example, petrochemical engineering, you have environmental engineers, you have biomedical engineers. So these are the sub branches of those four big branches. So for example, let's look into chemical engineers, where there is an element of petrochemical engineers as well, where the petrochemical engineers, basically, they are dealing with the plastics and polymers majorly, but we do have something like similarity with the chemical engineers. And of course, we are involved in the medicine production, food production, and so on as well. And the other engineers, for example, biomedical engineers, we are involved in the medical services, surgical implants, prosthetics, and so on. So can you just imagine someone with an amputated leg can walk today? How is it possible? That is possible only through biomedical engineers and so on. And the materials they use, for example, hardened plastics, very strong plastics. So who are the producers of that? That's where the petrochemical engineers will come in. So these are the examples of where a few fields of engineers working together to make a product happen, or to produce a product which is useful for the people. So what are the engineering challenges in 21st century? First of all, we have a very essential need that we have to fulfill. One is to provide access to clean water. Probably in Malaysia, we have plenty of clean water, or plenty of water resources, to be exact. Clean water, we are still, there are various ways that can be done. In future, I believe that people will look into providing clean water access to everyone, regardless of the location and so on. And of course, we are trying to go away from fossil fuel electricity generation, and we are trying to make use of our tropical country. For example, in Malaysia, we are trying to making use of the solar energy that is available throughout the year, to convert it into electricity and to be supplied for the households and the industries. Then, of course, we are going into the reverse engineering the brain and so on. So these are very advanced technology, which is fundamentally built upon the engineering and science knowledge. So that's about the, can you just, after presenting all these things, probably you can think of is it possible to have a world without engineering and science? Probably, if there is no engineering and there is no science, we would be still probably there won't be any evolution happen. There won't be any knowledge sharing. There won't be any products that we are using at the moment. We will be just probably, I don't know, it's very hard to imagine. So to be honest, engineering and science has become an essential need for the 21st century, and it will carry the weight in the coming centuries as well. So with that, thank you. That's all for my presentation. And I shall pass it to my colleague, Dr. Singh, to further explain about the engineering field that we offer in Utah. Thank you.
Okay. Okay, thank you, Dr. Gopi. So I'll share the screen. So good afternoon, okay, to all the students or audience. So I am Dr. Sin from Department of Petrochemical Engineering, the same department with Dr. Gopi. Okay. Today I'm going to introduce the engineering program at Utah. We have two engineering faculty. Okay, one is Faculty of Engineering and Green Technology. Okay, our main campus, the Para campus, our main campus, the Kampa campus. Another will be the Faculty of Engineering and Science, our Kuala Lumpur campus, which is located at Sungai Long. So in Faculty of Engineering and Green Technology, we have 4 engineering programs. We have electronic engineering, we have environmental engineering, we have industrial engineering, and petrochemical engineering. While for the Faculty of Engineering and Science that located at Sungai Long, we have several engineering programs. For example, biomedical engineering, chemical engineering, civil engineering, electrical and electronic engineering, electronic and communication engineering, material and manufacturing engineering, mechanical engineering, mechatronic engineering, and electronic computer networking. So in this webinar talk, we will focus on the engineering program in FEGT, especially petrochemical engineering. So here is some image of the FEGT campus. So here's our FEGT campus, and we are facing a very beautiful lake. Okay, this is the night view of FEGT campus, and this is our engineering workshop. And each of the engineering program, we have our own engineering workshop for the student to run their practical experiments. So here I would like to mention that our Utah is very big. Okay, the Utah Kampa campus is very big and provide a very good, comfortable environment for the student to learn and do research. So at the end of this presentation, I will share a video to show how beautiful is Utah. And we have a very beautiful landscape. It's embedded with nature and surrounded by a lot of the beautiful lake. So here is some image of our lab in FEGT. Okay, we have microelectronic lab, we have digital electronic lab, we have power electronic lab, and we have analog electronic lab. Okay, we also have technical drawing lab, biochemistry lab, and some lab equipment. Okay, the image of some lab equipment. And we also have the engineering workshop. Okay, the image of engineering workshop, lecture hall, and tutorial class. So our engineering program is a 4-year program, okay, with a total of 140 credits, and we have 3 trimesters per year. The January and the May trimester are the long trimester, which contain 14 weeks, while the October trimester is a short trimester, which contains 7 weeks. The student also need to attach to a company for their industrial training for about 12 weeks during their 3rd year of studies. And our programs are approved by Ministry of Higher Education Malaysia and also gain recognition from the Board of Engineer Malaysia and the Institution of Engineer Malaysia. We also have Industrial Advisory Panel, and collaboration from local and overseas university, industry, and government agency, as well as we have external examiner from well-known overseas university for our engineering program. So this is our first engineering program in FHD, Electronic Engineering. So electronic engineering is an engineering discipline where non-linear and active electrical components such as electron tube and semiconductor device, especially transistor, diode, and integrated circuit, are utilized to design electronic circuit, device, and system, typically also including passive electrical component and based on printed circuit board. So here are some of the electrical instrument, okay, or device that can be built from electronic engineering. For example, smartphone. So the career prospect, some career prospect of electronic engineering will be the electronic engineer, product engineer, material research engineer, and process engineer. While for the second engineering program in FEGT will be the environmental engineering. So environmental engineering is the scientific study to apply engineering principles to improve our environment, air, water, land, and nature resources, to provide healthy water, air, and land for human habitation and for other organisms, and to remediate polluted site. So just now, Dr. Gobi has mentioned that engineering, we can transfer those sewage water to a useful, for our daily life. So some career prospect for environmental engineering, environmental engineer, environmental planner and designer, environmental researcher. So EIA with environmental impact assessment consultant and an operator of pollution control facility. While for third engineering program in FEGT will be industrial engineering. So industrial engineering focus on applying engineering principles to improve the performance of an integrated system involving man or labor, okay, material methods and machine in the manufacturing, industrial and service center, which comprehensive and interdisciplinary. So from industrial engineering, we can reduce the manufacturing cost, increase productivity, improve the quality of our product, reduce the waste, and eventually increase the profit of the company. So here are some career prospects from industrial engineering, industrial engineer, production or process engineer, schedule or planning engineer, project engineer, supply chain engineer, and cost or operation analyst. So this is our fourth engineering program in FEGT, petrochemical engineering. For petrochemical engineering is the application of science in particular chemistry, physics, and mathematics to the process of converting raw material of petroleum or other hydrocarbon origin into more useful or value products. So for our petrochemical engineering, we are very relevant to chemical engineering. Why? Because core subject of chemical engineering, for example, mass balance, energy balance, mass transfer, energy transfer, thermodynamic, chemical reaction engineering, and many more. The student will study in petrochemical engineering. But in addition to this, the student also study some petrochemical element subject. For example, occupational safety and health in petrochemical plant, okay, polymer process engineering, environmental pollution and control in petrochemical industry, equipment design for petrochemical. So this means that the student after graduate for petrochemical engineering, they can employ in either chemical or petrochemical industry. Here are some career prospects from petrochemical engineering, gas engineer, petrochemical engineer, chemical engineer, advanced material engineer, specialty chemical engineer, food processing engineer, pharmaceutical engineer. So here I would like to present the petrochemical market, and from the research shows that the global petrochemical market was predicted at USD 441 billion in 2019, and it's expected to witness a compound annual growth rate of 5% over the forecast period. Okay, so the growth of the market for petrochemical will be driven by rising demand for the downstream product from end-use industry and capacity addition in the base chemical industry. So those downstream products include plastic, okay, plastic resources, synthetic rubber, adhesive material, okay, a lot of downstream product that we demand nowadays. So why you should join us in petrochemical engineering? The student will acquire a wide variety of skills. Okay, so the student not only learn technical knowledge from chemical or petrochemical engineering, but they also learn about biochemistry, chemistry, and material science. However, they also know about economic, management, safety, and environment in the petrochemical engineering. And another point why you should join petrochemical engineering, which is highly employable. So according to our research, 95 to 97% of our Utah graduate can be employed within 6 months of the graduations. And petrochemical engineering is not a restricted choice. Why? Because even though the graduate who choose not to accept the job in industry, and also, okay, they are also highly employable in other areas. Because they are experienced in solving problem and have good analytical and management skill. And petrochemical engineering graduate or petrochemical engineering graduate, we have employed in a successful career in sales, consultancy, and also scientific journalism. Petrochemical engineering is a professional course, a holistic development of student employed in overseas and multinational company. For example, okay, our students have been employed in Huawei Technology, Javier Circuit, Hot Glove, Rubber Racks. Okay, here are some examples that I mentioned just now, and definitely suitable for both female and male. Okay, so here are very brief survey, okay, employment survey from our alumni that the student graduate after 3 months. So we can see that a lot of them employed after 3 month graduation, but some of them further study, for example, Master of Engineering, and some of them have their own business. This is the salary range, okay? The average is about 3,000 to 5,000, okay? After 3 months of graduation, which means that they are fresh graduate, okay? So now I would like to share some student activity in our Department of Petrochemical Engineering, okay, within these 2 years, 2019 to 2020. Okay, our student actually has been actively participated in a community project, for example, municipal waste management project. So in this community project, the student create awareness on recycling the household waste, okay, among the community in Kampung Bali, Perak. And our student also won a 2 gold medal and 2 bronze medal in an innovation and invention competition through exhibition 2019. This is another competition that our student participated, which is ChemECA competition. And ChemECA competition is an annual event, okay, that organized by Institution of Engineering of Malaysia. So from this competition, the student applying their knowledge and skill that learned from the, for example, chemical reaction engineering or organic chemistry during the construction of the chemical base car. You can see that the photo of the left-hand side, okay, the student are building its own chemical base car. So our Department of Petrochemical Engineering, we also invited experts from different industry. For example, Mr. Kartik, okay, from Petronas Senyam Berhad, to give a talk on IR 4.0 in transforming the petrochemical industry on 4th of April 2019. And our student also went to field trip to Petronas Chemical Fertilizer, Gurun Kedat Senyam Berhad, okay, to visit the plant, to know how Petronas Chemical Fertilizer works, okay. And this is an intern sharing poster competition. Okay, so in this intern sharing poster competition, the final year project student, okay, will present their research work to their junior internal panel and industrial panel. And this intern sharing poster competition in FEGT, we carry it twice per year, okay, which is on the January and May trimester. Okay, so this is another technical talk from expert. Okay, we invited Miss Wee from Malaysia Phosphate Additive Sarawak to share her experience on planning and evaluation of a project. So another field trip for a student to Tuklov on 1st of August 2019. So this is another intern sharing poster competition on May trimester. Okay, so on 21st August 2019 in FEGT. This is another community project that our student participated, water quality monitoring on Sungai Kinta. Sungai here means river. Okay, so in this community project, the students are helping, okay, the Grover Environmental Center to monitor the water quality. For example, turbidity, pH, total solid, and dissolved oxygen in the Kinta River. So another field trip to YTY industry, which is the glove industry, on 22nd October 2019. Okay, this our student, okay, won a gold and a silver medal in the Police International Engineering Invention and Innovation Exhibition. Okay, recently on 18th to 21st May 2020. Okay, this is another industrial talk. We invited IR Chan from Dialogue Group Berhad and Mr. Fong from Lotte Chemical Titan to give a talk to our student on an outlook of the future of petrochemical industry in Malaysia. We also invited Mr. Au, okay, from iCircle Malaysia Sendian Berhad to give an industrial talk on the sustainable recycling system for eco-shopping, community awareness and action to our student. So this is another competition. Okay, our student won a silver and a bronze medal in an innovation and invention competition through exhibition 2020, which carried on at 21st July 2020. This is another talk on the wastewater treatment system in the glove industry that given by the engineer from Top Glove Sendian Berhad. And we also invited Mr. Yu, a chemical engineer from Kahir Corporation, to share his experience, okay, in distillation process in industry or in chemical industry. So our students not only learn their knowledge through lecture, actually we also invited a lot of experts and send them to bring them to field trip to different industry to gain more experience, to gain more knowledge from different parts. So here I would like to share a good news. IR Chan Yu Kai from Dialogue Group Berhad offer a very generous scholarship of full tuition fees to our petrochemical engineering. Okay, here are the details. So before I end the presentation slide, I would like to share a video to show how beautiful is our Utah. See you at Utah.
Okay, thank you to our speakers today, who Dr. Gobi and Dr. Sin, okay, who share this information and amazing information with us. That's awesome. And so now we move on to our Q&A session. So just a reminder to our friends here, please raise your question in the Q&A button. Due to the limited time, we are only able to pick some question to answer. So now we open question from the floor to ask our speaker. So any question? So while waiting question from the floor, so maybe I have a few questions to ask Dr. Gobi or Dr. Sin here. So what is the challenging and the best part when students choose to study petrochemical engineering program, and also a condition to register as an professional engineer? Yeah, maybe Dr. Sin or Dr. Gobi can answer us.
Okay. I'll answer on the professional engineer part first. Okay.
Yeah.
So the student that graduate from, for example, petrochemical engineering, the student that graduate from the petrochemical engineering, they'll become a graduate engineer in Board of Engineer Malaysia. And after they can work, okay, after they accumulate a certain period of the experience, they can apply for professional engineer. There are some route, okay. So for more detail, we can go for Board of Engineer Malaysia to have a look at that. We have a route, okay. So either they can accumulate about 2 years of experience and get a mentor to guide them, and then apply for professional engineer. So once they become a professional engineer, they have a right, okay, to sign those chemical-based project. Okay, this is for petrochemical engineering on a professional engineer. Well, for the, what's the question just now? So sorry, Jeffrey.
And also a condition to register as an engineer.
Conditions.
Yes.
Condition, which means that you need to, yes, Dr. Gobi.
Yeah, I mean, for your information, Jeffrey, actually, once you graduated from Utah, you are eligible to register as an engineer. I mean, to register in IEM, Institute of Engineers Malaysia, as well as Board of Engineers Malaysia. So we are accredited by the BEM, the EAC. So we do not have any problems of registering as an engineer. After registration, then you can go ahead with the route to become a professional engineer, where you'll be granted the IR title. That's the long-term plan.
So just an add-on question, yeah. Does this apply to our international student and the professional qualification route for international students?
As an international student, if they opt to work in Malaysia, they still can register, but then there is a special board that will consider the application, where they will register themselves under the BEM, because they are graduated from Utah, so there won't be any issue regarding that because of their qualification. There might be a special requirement for them to register in their home country as well. So that depends on the arrangement and so on. So as a basic thing is they can register as an engineer under Board of Engineers Malaysia.
So I would like to add on some info on that. So for our student or international student, they also can apply chartered engineer. Okay, in addition to professional engineer, they still can apply for the chartered engineer. For example, IChemE, okay, for those chemical engineer or petrochemical engineer. Okay, they graduate from a chemical engineering and petrochemical engineering. Okay, thank you.
Thank you. Okay, so instead learning in the class, right? Maybe in a lecture class. So any chances for students to take part in engineering research project in Utah, which maybe collaborate with industry, like our Utah undergraduate research scheme, that they maybe can learn beyond the class?
Yes, of course. For your information, we have many collaboration projects with the industries. In fact, Utah has been promoting the collaboration between the faculty and the industries, and many of our staff has participated in this collaboration, and many FYPs for the past 2 years have been industrial projects, where FYP means final year projects, have been industrial based projects, where we solve their problem, probably for a short-term problem. If there is a long-term problem also, we will give initial idea on how to solve it by after doing some basic research on the topic. Probably Dr. Sim, want to add anything?
Thank you. So for the previous question, right? So can Dr. Copy just highlight on the Washington Accord information?
Yeah, the Washington Accord information is basically what is it all about is it's basically the eligibility of your degree throughout the world. So basically, as we know, EAC is whenever we are being accredited by the EAC, we are complying the Washington Accord. So in that case, what happened is whenever we are applying if we want to further our studies in any other countries, for example, in UK, Singapore, any countries, our basic degree will be applicable or eligible to be considered for the master studies and so on. Apart from that, you can work as an engineer in other countries as well, because your Utah degree is being accredited and it complies the Washington Accord. So in that case, we are employable throughout the world, wherever the Washington Accord is acceptable or being accepted, then we can work over there.
Thank you, Dr. Kobe. So for the last question, maybe what is your advice to our potential student here if he or she is going to take up petrochemical engineering in Utah? Or maybe Dr. Shin or Dr. Kobe can share with our student.
Kobe, you first.
Okay. First of all, we would like to welcome you with open hand. Of course, we are very much ready to accept the new students, and we are very excited to receive you, because we know many of you have a kind of different perspective on what the petroleum engineering would look like and so on, the job prospect and so on. But the truth is, we have a very big potential or very big future if we choose the petrochemical engineering, because we are relying on the petrochemical based raw feedstock, which will be very cheap when the petrol price goes down. So we are actually benefiting out of it, rather than we are being jeopardized by the oil price and so on. We are actually benefiting from the low price of the petrochemical feedstock. So in that case, the petrochemical engineers are very much marketable. And as Dr. Sin has highlighted beforehand, our employability is very high. So it shows that the petrochemical engineering graduates are actually very marketable, even though in an economic crisis and so on. So there is no issue about the job security and so on.
Okay. Same. I welcome the students to try petrochemical engineering. So in my presentation just now, I have mentioned that global petrochemical market. Okay, which means that the global petrochemical market actually is growing. Okay, among the forecast period according to research, with a 5% growth. And our petrochemical engineering graduate from Utah, our department, they have employed in very good company, for example, Huawei Technology, okay, with very good pay. And also Utah graduate, actually, we are accredited by those professional body and Ministry of Education Malaysia. So there's no issue for them to further study to, for example, further study in other overseas university. Okay, and also our students won a lot of competitions. So I believe that this actually can promote our students in a lot of international competition, local competition. So I hope you don't have any wrong perspective on petrochemical engineering. Actually, we are the same as chemical engineering. So very relevant. So see you at petrochemical engineering. Thank you.
Okay, thank you, Dr. Sin and Dr. Kobe. Thanks for your sharing. Okay, also, thank you who shared this valuable info with us. So we are about to end the webinar session now. As we mentioned earlier, Utah do offer engineering and green technology program. So I will give you all a quick look with some of our Utah info here. So as you all can see, okay, we have our award-winning Kampa campus in Perak. So this is our main campus, and our branch Sungai Long campus in Kajang, Selangor. So okay, I'm sharing this with you. Yes, you can see this is a area view for our Utah Kampa campus on 1,300 acre piece of land, and this is our Tun Dr. Ling Leong Sek Ho, and our branch Utah Sungai Long campus. So I'm going to share with our friends here. This is our Utah rankings and awards. So I'm not going to read one by one, but we can highlight for the World University rankings in 2021 from 501 to 600. And we have our outstanding educational institution, okay, and a premier digital tech university status by MTech. Okay, and also we have tier 5 in excellent result in this D Setara for engineering. Okay, and also we have this 5-star excellent result, okay, in Setara 2017 Emerging University. Okay, for this QS graduate employability rankings in 2020, so this is our ranking and result. So 251 to 300. Okay. So the Utah programs that we offer, okay, we have 119 academic programs, which is consists of 4 foundation programs, 72 bachelor's program, and 31 master programs, and 12 PhD programs. Okay. So this is the areas of studies. Okay, we offer business field program and art and social science, creative industry and design, okay, engineering program, IT program, sciences program, and so on. Okay, so for the FEGT program, engineering technology and built environment program, we have at Kampa campus, we have construction management, electronic system program, industrial management, environmental occupational safety and health program, and electronic engineering, environmental engineering, industrial engineering, and petrochemical engineering program. Okay, so the professional recognition which we would like to highlight here, as Malaysia is a signatory of the Washington Accord, as our speakers share with us just now. Utah engineering degrees are recognized by each signatory as being substantially equivalent to accredited or recognized qualification within its own jurisdiction. The other signatories of the Washington Accord includes Australia, Canada, China, Chinese Taipei, Hong Kong, China, India, Ireland, Japan, Korea, and the countries here, and so on. So we move to the next. So this is the international collaboration that Utah has established over 56 MOUs, MOS with locals and overseas universities, and over 180 local and overseas industry in 28 economies. Okay. So now I will just pass the floor to our colleague, Ms. G, to share some info with you regarding the international information.
Thank you, Jeffrey. So I would just like to add on a little bit about our university. So as Mr. Jeffrey has mentioned just now, we have 2 campuses and we have about 119 programs ranging from foundation, degree, and postgraduate. So UTAL, we do have a wide range of MOU partners and also a collaboration with industry partners to ensure that our students are well equipped, not only in academic, but also in the industrial exposure as well. So for now, we have 22,000 students at both campuses from 44 economics. Okay, so next we would like to share with you about the program fees. Next slide, please. Okay, so this will be the program fees for international students, and then for Malaysian engineering program for 4 years is about 51 to 52,000 for the 4 years, and for international students we will be charging about 14 to 16,000 USD, depending on the engineering program selected. So the fees offered or charged by UTAL is relatively low as compared to other private universities. So it's not a problem, and we do offer scholarships for students, international students as well. So you can always approach us. You can also talk to us to find out more about these scholarships. Next slide. Okay, so when we talk about the living expenses at both campuses, you can estimate or you can put a budget of about 300 USD to 400 USD, which is actually quite sufficient to survive, in both Sungai Long and also our Kampar campus. And then apart from the tuition fees, living expenses, you will also need to allocate a budget for the EMGS charges, which will cover your visa, medical screening, insurance, student pass, and so on. So for the first year, it's about 550 USD to 1,000, and then for annually, the renewal will only be about 170 to 180 USD. Okay, so let's talk about the entry requirement. So this entry requirement basically applies to both locals and international students holding the equivalent or same academic qualification. So for foundation level, students with O level, or in Malaysia we call it SPM, you will need to have at least 5 credits, including the relevant subjects, which is like mathematics and also 2 science subjects. So with this minimum requirement, you are eligible to apply to our university's engineering or even other science subjects program. And if you are holding A level, you will need at least 2 minimum passes, advanced passes, as subject required by the university. So A level is also equivalent to STPM in Malaysia. So if you are holding SPM or STPM, you can just refer to the same requirement. And if you are not sure, you can always approach our academic advisors or our program advisors to find out more about it. All right, so for international students, there is an additional requirements, which is the English language proficiency. So for international students who are coming in for the degree program, you will need at least IELTS 5 points, or if you are taking TOEFL IBT, 42 points. So this is the equivalent chart that you will need to have for your English requirement, depending on the level or on the test that you will be taking. So for international students who do not have any English requirement before you apply, you can also opt to take up our English enhancement program, which lasts to about 3 to 9 months, depending on your English level. So after the English enhancement program, you will have to take for the IELTS or TOEFL, or even if you're in Malaysia, you can take for the MUAT exam before you start your core program. Okay, so that would be the information for international students, additional information for international students. So I will pass the time back to Mr. Jeffrey to further explain for our upcoming webinars.
Okay, thanks for sharing, Ms. Jin. So we move on to the information which we would like to share with you. The upcoming webinar we have for tomorrow, 22nd of September 2020. So this is a 1 hour and 30 minutes webinar. We should talk about overview of enterprise risk management and industrial manufacturing perspective. So hope to see you tomorrow. And so for further information for you and your reference, if you would like to know the information which UTA the program we have, like the scholarship and club and society, all the information you can just log on to our website www.utah.edu.my, or for program inquiry, you can program information, you can just log on to study.utah.edu.my or /CN for Chinese version. Also, you can update our information from time to time at our Facebook page. You can just type Utah for you or UtahNet, and you can view our latest info over there. So maybe you can add us at our WeChat account, UtahNet, or maybe you can feel free to call us at our hotline at 016-2233-557 or 016-2233-559 for if let's say you are from other country, like a foreign country, like overseas, 016-2233-559, or maybe you can call us at 011-1107-3427, or feel free to drop us an email at inquiry@utah.edu.my or international@utah.edu.my, and our education advisor from our division of program promotion will answer your question. So once again, thanks for your participating, and we hope to see you again, and thanks to our speaker today. Thank you.